So guys, listen, we have a shorter lesson today, and you should be able to finish your homework in class. Yay. Okay. So we're going to do examples 7, 8, and 9, and then I think it's 10 homework problems. First thing you might notice is I've highlighted this box here. These are called the sum and difference formulas. Notice that we have a sum and difference for sine and a sum and difference for cosine. Okay? These you will have memorized by the end of class, and they have to be memorized. Okay? I promise you this is not a difficult thing. This girl who can't memorize anything, I didn't have these memorized before today. I actually was, I'm not going to lie, I was stressed a little bit thinking, how am I going to memorize these, much less teach them how to? And I did all this research, and there's a whole like group of people in my AP Pre-Calc group that are all talking about these. Oh, I tell a whole story about sine dating cosine and blah, blah, blah. And then I figured it all out. I promise you, that's the only thing that if you're stressed about that, don't be stressed. Gone, okay? Let me explain a bunch of patterns here, okay? So first thing I want you to notice is that in all 4 of these formulas, there's these weird letters in the parentheses that are in the same order. These are Greek letters alpha and beta. They are angle measures. Sometimes we use x, sometimes theta. They're just variables, okay? But I want you to notice alpha, beta, alpha, beta, alpha, beta, alpha, beta. Okay, that order stays the same in all of the left sides of the equation. And then look at the right side. Alpha, beta, always. Alpha, beta, and same here, alpha, beta, okay? So the alpha, beta order is non-negotiable, okay? Yes, it is permanent. It will never change. Now, look at the 2 sine formulas. We have our sum and we have our difference, okay? Notice that when we expand it on the other side, we also have a plus. So plus, plus, minus, minus. So sine starts with an S, and so does same. They have the same sign in the middle. Look at cosine. Here's the sum and difference formula for cosine. And in these 2 formulas, the sign in the middle changes. So instead of plus, we make it minus. Instead of minus, we make it plus. So I'm going to use the word change because it starts with a C, right? Cosine, cosine. Okay, so that's the first thing, so second or third thing I want you to notice. Another important, and when I model this for you, like right now I'm telling you a whole bunch of stuff, you're like, what? I don't know what she's saying. When we do the 2 problems right here, I promise you, we're going to be fine. Every single time we're given these problems, whatever is written first here is what goes first here. So if you notice it's sine alpha, that's what you start with. Sine alpha, that's what you start with. Cosine alpha, that's what you start with. Cosine alpha, that's what you start with. And the last thing is the order within the problem. So see how this is sine, cosine, cosine, sine? One person in my group said, oh, just teach them this letter setup. SCCS, sine, cosine, cosine, sine, sine, cosine, cosine, sine. And then with cosine, it's CCSS, and that's fine. I love to pass on things that people share with me that might help this person and that person. What I like to say, and this is what I'll keep saying that will help you with that order, is that sine is social, likes to intermingle with people. Sine likes to go out, have a good time, talk to other people. So sine and cosine mix together in the sine ones. Sine is social, so sine is going to find another friend. It's not just like them. Okay? Cosine is antisocial. Cosine stays with cosine, and then sine with sine. Okay? Now, if you're still confused, that's normal. Don't worry about it. I promise you, something is going to stick with you. Every class today, well, all 2 of them, no one even complained. They complained at the beginning, and then they were like, oh yeah, it's easy. Okay, so just trust me on that one. Tomorrow we're going to do double angle formulas, so I'm not even going to bother with that. We're going to go right down to what do we use these formulas for. Okay, so 2 different ways we'll be using them today. One is these 2 examples, which is finding the exact value, and I'll go into that deeper in a second, and using these in proofs. Okay, so what this is, 7 and 8 is asking for an exact value of sine of 5 pi over 12. What that means is let me put it into perspective for you. If I asked you what the exact value of cosine of pi over 6 is, you would say square root of 3 over 2. All these green numbers, those are exact values. So when it's asking for an exact value, it wants those. Well, we don't need special formulas anymore for the numbers in green because those are our standard angles. These are ones we work with all the time. We've memorized them. We know them, I hope. Okay? But 5 pi over 12, that's in between some of our standard angles. We don't know what the answer is. So they gave us a formula, sum and difference of sine and cosine, to find it. So they even go as far as to tell us that 5 pi over 12 is made up of these two angles. If you add these two angles together, sum, you would get 5 pi over 12. How? Common denominator. Okay? If I made these both a 12 and added the numerators, trust me, you would get 5 pi over 12. So what they're saying here is we're going to be using our sine formula, because it's sine, and the sum. We're going to be using this first formula. The first angle you get to, this is called alpha. I think I said it, I don't remember. Greek alphabet, A, beta. You might see X, you might see theta. You don't have to, I'm not grading you ever on how well drawn your Greek letters are, because mine are always not pretty. So don't stress about that at all. If you want to make it an A and a B, that's totally fine. Okay, just wanted you to know that. So I'm going to do sine, and I'm not even going to look at the formula. Try not to look at the formula with me and just see the patterns here with me. So this is addition. I'm just going to keep it in the same order they gave it to us, but technically you could have put pi over 4 first, because it's addition, right? And so, but since we put it in this order, pi over 6 would be alpha, pi over 4 would be beta. That order is non-negotiable. Okay, so I'm going to expand it. So I'm going to expand it to the right side of the equal sign over here. So I always start with whatever we started with there. So sine of pi over 6. That's how I start. And then I'm kind of on my own. Don't even look up there. Think to yourself, okay, sine is social. Sine mixes with cosine, social. And so I used pi over 6. Now I'm going to do pi over 4. Because remember, it always goes alpha, beta. It's never going to be alpha, alpha, or beta, beta. It's alpha, beta, every time. All 4 formulas. Then sine starts with an S. That means same, plus. Now here's where I worry that we could make a mistake. How do I remember? And I thought about this. I thought, how do I teach them to do cosine first and then sine? Well, here it is. Because you might want to, you might do sine first and then cosine. Here's the thing. If you remember that alpha and beta have to go in that order, you know this next one's going to be something of pi over 6. So it's pi over 6 and pi over 4 in that order there and here. And we don't have any repeats in here. So if I accidentally put sine of pi over 6, I'm repeating the same exact trig function. So I'm mixing it up. I need to have everybody represented. And then, of course, social, so cosine and sine hang out together. Notice alpha, beta, mixing sine and cosine, mixing sine and cosine, and there's no repeats. Sine and cosine of pi over 6 is in there, sine and cosine of pi over 4 is in there. All 4 are represented. There's no repeats. If you remember some of those tiny little details, by the third problem we do, you won't even need to look up there. All right? Now what do we do? Well, the whole purpose of this formula was they took 5 pi over 12 and gave us 2 standard angles that we do know a whole bunch of stuff about. We know, and if you want to write it somewhere, that's fine, pi over 6 is square root of 3 over 2, 1/2. Just we need to get back on the unit circle. It's never going away. Pi over 3, that's the one up towards the y-axis, is 1/2, square root of 3 over 2. And we're just going to plug those values in wherever it's appropriate. So sine, and remember, cosine comes first, then sine, alphabetical order. So sine of pi over 6 is 1/2. Cosine, oh, why did I do that? We don't need pi over 3, we need pi over 4. We need pi over 3 for this one, so it's fine that we wrote it. I don't even know if you have to write that one, right? Square root of 2 over 2, square root of 2 over 2. So cosine of pi over 2 is square root of 2 over 2. Plus cosine of pi over 6 is square root of 3 over 2. And sine of pi over 4 is square root of 2 over 2. And now we simplify it as far as we can. So I'm multiplying two fractions. That means I multiply the numerators and I multiply the denominators. So I get 4 in my denominator, and 1 on the outside, I don't need to write that, in the square root of 2. Plus 2 times 2 on the bottom is 4. And with multiplication, I can multiply these two together. Square root of 3 times the square root of 2 is the square root of 6. But that's as far as I can go. Even though we have a common denominator here, I mean, the best I could do is write it as one big fat fraction. You could share it, because they do have the same denominator, but I cannot actually add those two numerators together. They have to have the same radicand, the same number underneath for you to add the numbers in front. Okay? Like, let me just show you. For example, if I had like 3 square roots of 2 plus 4 square roots of 2, that would be 7 square roots of 2. Okay? So since these are not the same radicand, I cannot add them either. That's as far as you go. You could write it either way. Okay? Now, yeah. Which is what? Okay. So, what are you thinking that could be? So you're right, you could do the square root of 6 equals the square root of 3 times the square root of 2. So I guess one thing you could do, if you wanted to, I'll use this paper right here. So if you had the square root of 2 plus the square root of 6 over 4 and over 4, you could factor out the square root of 2, but it really doesn't simplify it. So you would have the square root of 2, 1 plus the square root of 3 over 4. Right, Michael? Do you see what I'm saying? You're still stuck with a radical that you can't add them together. So this does equal this. It's just the reverse of the distributive property. They do have a square root of 2 in common, but it still doesn't allow us to do much with it. Okay? Right? All right. So understand that they're giving us, same exact type of problem, they're asking for cosine of 7 pi over 12, and they're telling us what two angles add together to get 7 pi over 12. When we get to the homework, I'll do one with you, but you have to come up with the two angles. How do you do that? Well, I'll show you, but what I want to get at is you can use any angles on the unit circle. You can use any quadrant. You can, if I said, figure out 5 different ways to make a 7 pi over 12, I don't know if there's 5, but there's usually 2, 3, 4 maybe. You could subtract any two. You could subtract one of these big ones in this one minus something over here, or add 2 in this. Like, whatever you can do, you can use any two you want, and you can add or subtract if you're coming up with your own. All right? As long as you're using your two angles here equal the one you're trying to find, that's all that matters. And you get the same answer no matter what, okay? Because it is the same answer. These are a little easier because they give us the two angles. So again, I'm just going to remind you of this moment in a few minutes when we do one of these in the homework together of what I'm talking about. But since they gave us those two, we'll just take them, all right? So make those a common denominator of 12 if you wanted to check it, but these two add together to get 7 12ths. Okay, we're doing cosine, so that's established, and they gave us it written like this, so it's going to be cosine addition. So I'm going to just keep it in the same order, although since it's addition, it doesn't really matter. Which means this is alpha, this is beta. That's non-negotiable, that order. Now I'm going to expand it. Try not to look up at the top of the paper. You guys have an open note quiz on Tuesday, so you don't have to have these memorized by Tuesday. But if you just try to memorize them now, they'll be in your brain and you won't have to worry about it later, okay? So you always start with exactly what's written there. Okay? And then you go, okay, cosine. Cosine is not social. Does not want to go out and mingle with others. Wants to stay with another cosine. So there's alpha and beta. Are we going to put a plus or a minus next? Minus. C means change that sign. S means stay the same. Okay? And now, I don't think you'd mess up. You're not going to put cosine, cosine again. Now here comes sine and sine again. And we keep alpha and beta in the same order every time. that's it. Let's just plug, not that's it, but that's all we have to do for that. So start plugging in our numbers. And let me talk about why these answers look so funny. Pi over 3 cosine is 1/2. I mean, almost every single answer you get is going to have a square root of 2, a square root of 6, and a 4 in it. Because those are really the only numbers on the unit circle. Some of the signs will change, or if they throw in the quadrantals, you could have some different answers. But other than that, you're going to have a lot of answers that look like this, as you'll see right here. You get the square root of 2 over 4 minus the square root of 6 over 4. Again, you could write it as one big fat fraction like we did here. You could factor out that radical like Michael was just talking about. But that's the answer. Now, why does it look so weird? Why are these answers like 1/2 or square root of 3 over 2? Well, if I did cosine of pi over 6 in my calculator, I would get this answer, but it'd be a decimal. It wouldn't be exact, okay? If I did sine of pi over 6 in my calculator, I'd get 0.5, which, okay, we can handle that. But when we're talking about exact values, you can't have a non-repeating decimal, an irrational number, which is what you would get if you put this in your calculator, okay? So we just leave it in most simplified but exact form. It looks funny, but that's what it is, okay? Last one is a proof. Now, when I have taught this material in all the other years I taught pre-calc, which was honors, I taught all the same stuff for the most part. There's a few things in this course that is different. We definitely do more. As I told you, I think I told you, in the past, yes, I told you, they didn't have to memorize formulas, so that was a little bit easier. What was that sound? Oh, so but whenever I teach, the last 2 days that I've been teaching you guys those proofs, those were hard, okay? One of the hardest things, if not the hardest things we do all year, is what we did the last 2 days, okay? When we get to this moment of proofs, I love it because I get to say, now it becomes easy. Doing proofs or verification problems when you have a sum or difference is so easy because the hardest part of all proofs, except these, is knowing what the first step is. How do I start it? When you see a difference or a sum for sine or cosine, you know that formula. That's how you start it. That's why these are easier. So again, try not to look at that other page. We're going to rewrite this left-hand side to look like the right-hand side, okay? So you always start with what you exactly see. So that's sine of pi over 2. Okay, sine is, so this is alpha, this is beta. Sine is social, so I'm going to do cosine of x, alpha, beta. Plus or minus? S is same. This stays the same. And by the way, I meant to say this back here. On this problem, some people are getting confused because it's a plus here and then there's a minus here. We don't make up the formulas. That we can't change them. Just know that when you add, sometimes in the formula it's subtraction, okay? And that came from up here. Don't overthink that. But with sine, it's always going to be the same, okay? So if you see minus there, you have a minus there. And then remember, we want to have alpha and beta. It's got to be pi over 2 and x in that order, non-negotiable. So I'm not going to do sine of pi over 2 again, because we don't want to repeat. We'll put cosine of pi over 2 times sine of x. Social, social, alpha, beta, alpha, beta. No repeats. Okay. I have to make this mess just cosine x. So let's identify what sine of pi over 2 is. Remember, pi over 2 is up at the top, so that would be 0, 1, right, up at the top. So sine of pi over 2 is 1. Cosine of pi over 2 would be 0. So 1 times cosine x is just cosine x. And then 0 times anything is just 0. We did it. Right? 0. So you have cosine x minus 0. Just cosine x. So the proofs are the easiest ones. They're really, once you know that pattern, they're always this stuff happens right here. Exactly, pretty much the same every time. All right. Let us go to the homework. Practice set 2. It's written on the board right behind me, but I'm looking for it. I don't know where it is. I know, but I can't find my key. Oh, here it is. Sorry. It's on page 146. I'm going to do 1 and 7 with you, because we didn't have those types in our notes. We have this written down. Okay. All right. Yeah, I'm going to do 1 and 7 with you. You don't have to do 4. Okay. So look at number 1. It's the directions for this whole page is to find the exact value, which is what we were doing in the first 2 examples. There's no proofs here. On the next page, 9, 10, 11 are the proofs. So we have to simplify these. 5 and 6 are just like what we did in the notes. Okay, that's what we did in the notes. Look ahead, and I'm going to do number 7 with you. This is where you have to come up with 2 angles. So I told you I'd show you how to do that. Well, what the heck is this? This is just working in reverse. We have an expanded, it's like they're giving us the right-hand side of the equal sign. We need to write it as the left-hand side, because we don't, what is pi over 18? I don't know. We don't know what those values are. So let's work in reverse. What we want to do first, though, is determine what are we looking at. Is it sine? Is it cosine? Is it sum? Or is it difference? We do that by looking at the pattern. So if you look in the left-hand side of our plus sign, we have sine and cosine mixed. Just by seeing that, we know which one is this, sine or cosine. Which one? Sine, because sine is social. Sine mixes with cosine. Okay, so we know this is going to be sine, and so now that we know it's sine, we know that this is going to be addition because it's the same sign in the middle. So that's alpha, beta, non-negotiable. So what we're doing here is pi over 18 plus 5 pi over 18. There's my alpha and my beta. So far. Okay, because we don't have, it says to find the exact value. So we need to get square root of 3 over 2 or whatever, like we were just doing. So when I add those two together, what do I get? 6 pi over 18, right? 1 pi plus 5 pi is 6 pi. Well, what is 6 over 18? I don't know that angle, but always remember to do what? Simplify your fraction. Always simplify your fraction. 6/18 is 1/3. So pi over 3. And there we can find the exact value of that in our brain. Pi over 3 is up close to the y-axis. We want the second number. That is square root of 3 over 2. Okay? So that's how you're going to do 2 and 3. Same exact way. 5 and 6 is just like our notes, but you definitely want to do number 7 with me. Now remember what I was saying to you, and I'll repeat it a little bit here. In the notes, they were really nice. Instead of giving us 5 pi over 12, they would give us like what the two add together to get it, okay? How did they come up with them? Well, knowing we need a denominator of 12, we would change our quadrant 1 angles denominators to a 12. And so since we're not doing number 4, I'm just going to use that as some workspace. Let's take the 3 basic angles. I mean, you shouldn't even have to really write this down, but I'm going to go through it because multiple questions. So let's just do quadrant 1. I like to use quadrant 1. Even though you could use anything you want, quadrant 1 is the easiest because everybody's positive and we know the most about those. We're not trying to figure out signs or anything. So if I can use quadrant 1, that's what I always use. So if I want a denominator of 12, which I do for 7 and 8, I'm going to see what these equal with a denominator of 12. So 6 times 2 is 12. Pi times 2 is 2 pi. 4 times 3 is 12. Pi times 3 is 3 pi. And so on. Okay, so just finding what our standard quadrant 1 angles are with the denominator 12. Now, figure out which two you're going to add together to get 5 pi over 12. So that would clearly be this one and this one, right? 2 plus 3 is 5. So I'm going to use pi over 6 and pi over 4. Either order doesn't matter. Let's do the same one together so you're not confused in the work. But I'm going to rewrite this as cosine. We're going to add, right? We're adding the two together to get 5. Why did I pick cosine? Because it says it right here. And then pick which one you're going to go first. I'll just be nice and simple. Pi over 6, pi over 4. But again, if you were doing this on your own, you could have put pi over 4 first. Your answer would be the same in the end. Okay? Now we're at the same step we would be on 5 and 6, like in the notes, where we're going to expand that. Why is it what? No, this is adding because how are we going to make a 5 pi over 12? You add these two together. You're thinking of what's about to happen here. All right, so we start by writing what you see here first. That's how we start every problem. Cosine of pi over 6. Cosine is not social, not going to hang out with sine. Cosine only wants to hang out with cosine. And he's the boss since he came first. There's my alpha, there's my beta. Now, Levi, I'm going to put a what? Yes. Because cosine we change. So since we had a plus here, it would be a minus here. And now we do the same thing with our sines. Sine of, and always the order, pi over 6, sine of pi over 4. Shocker, we've got square root of 6 over 4, square root of 2 over 4, and you can write it one of those other ways if you want to. Okay? I will put the rest of them up in 1 second. You look at the pattern. Is it a sine or a cosine? It's sine. Alpha, beta, alpha, beta. You have to find a common denominator. So 5 pi plus 3 pi is 8 pi over 12, but then you have to simplify your fraction. 8 over 12. Divide the top and the bottom by 4. I'm not showing every step up there, but you should know. Common denominator. Always simplify your fractions, guys. You know. I'll give you a hard time.